Right, so in this question, we're looking at horizontal and vertical vectors. We've got due east and due north. We've got at 11 a.m., a ship leaves a port and moves with constant velocity, right? So it's constant velocity, there's no acceleration there. And we've got to show what that velocity is, and you look at the units if you're unsure what you're talking about. So we've got kilometers, so we know that's our displacement, and it's over 36 minutes. So we're trying to show the velocity in kilometers per hour. So we want to know how many hours are on the denominator, and on the top we want to know how much it's moved. So essentially what the vectors are telling us is that this is where I started, this is where I ended. I'm going to do this, take away this to find the displacement, so how much I've moved, and then divide it by the time in hours. So if I take my V equals 4i plus 6j, and I'm going to write the alternative if you prefer working in column vectors, and that's divided by the time in hours. So we've got 36 minutes out of 60 in total. So that gives me 4 minus 2 to give me 6i, and then I've got 6 minus 9 minus 3j divided by 0.6, and that will give me 10i minus 5j kilometers per hour. I could have written it as 4/6 if I find it easier to navigate, and that's also not a problem. So you end up with 6 minus 3 over 0.6, which equals 10 minus 5. But because it's given it to you in the IJ form, it might be better just to convert your answer in the last step to that. Okay, so part B. We're looking for a position vector. So what we want is an expression which tells us no matter where the ship is, how many hours it's been, we can plug t in and find the coordinates. So you might have seen it written like this. So R0 plus VT. R0 is essentially, where did we start? We started at minus 2.9. And every t hours, it's moving the equivalent of 10 across and minus 5 down, right? So what we're doing is saying, say we start here, and then we're moving 10 across and minus 5 down. Now, we don't really do that. We go along the diagonal, but it's represented by doing that. Now, what I would always do at this point as well, you could have left it like that, is write your solution and put your i's together and your j's together. So that's putting in column vector form. You can also write it as minus 2 plus 10ti, 9 minus 5tj. Preference is yours, however you've learnt it and whatever you find easiest. Okay. So now we've got at 12:48 a.m. a passenger on the ship notices the lighthouse is due east. So now if we think about it, if we draw our compass, my very dodgy one, I don't know how you ever learnt it. So if we have never eat shredded wheat. But anyway, northeast, southwest. Okay, we know at 12:48, what is t? So remember, we started at 11 a.m. So we've got 1 hour and 48 minutes. So I would write at 12:48 a.m. t equals, so 48 over 60, which is going to give you 0.8. T equals 1.8, so 1 hour. So if we substitute that into here, we're going to get R equals minus 2 plus 10 times 1.8, so 18i plus 9 minus 5 times 1.8, which is going to give you 9j. So you're going to get 16i, and the j's disappear, which makes logical sense because we're expecting it to be to the east of us. So let's put, actually what I'm going to do is let's take this line here, shift it a bit so you can actually see what I'm drawing. All right, so we've got, okay. So if we're also going to consider this our IJ axes, we're going to have 16i, which is going to be here. And we know at that point there, the lighthouse is to the east of that. So it's somewhere along this way. So somewhere on that yellow line. Okay. Now we're told at 1 p.m. So at 1 p.m. So that's when t equals, sorry, this should say 12:48 p.m. Apologies. That makes more sense. At 1 p.m., so that's when t equals 2. Okay. R equals, so let's plug that in. 10 times 2 is 20, minus 2 is 18. 18i minus j. Okay, so that's going to be further along. So 18i along here, minus j is going to be minus 1j along here. So that's going to be over here, right? So that's where I am as the ship. And where you notice it's northeast, so it's along, if you like, it's in this direction. So it's going northeast from that cross. Right, I hope that makes sense. I'll draw that a bit bigger down below. So that means you can easily see where the lighthouse has to be. So if I redraw it down here, so let's say this is your 16i. We said when we're at 16i, we want it to be across here. When it's 18i and minus j, so let's say here, and it's my very, very bad scales. Let's make this longer so it's a bit more obvious. Okay. It's along here, and we know that northeast is something in this direction. So if I'm starting here, northeast for me is going to be in this direction. So northeast for me is going to be essentially this pink highlight, and I need both those things to have been correct. So therefore my lighthouse is over here. Right, now I have to work out what that is. So if I think about it, I know that it's northeast, so it's exactly 45 degrees there, which is like as if the line y equals x. So I know if this is going up 1, because we know that's minus j, so that needs to go across 1. So if that's 18, this point here must be 19. So therefore my lighthouse must be at 19i, and that is the position vector of my lighthouse. Right, next step. We've got to find the position vector of the ship when it's due south of the lighthouse. So when it's due south, what do we know for definite? So we've now got our lighthouse, which is over here. Sorry, my big L here. And that's maybe, no, I should try not to make this look too strange if anyone's just looking at this as work solutions. Right, so that orange dot, and I know that it's due south. So due south means it's going to be going vertically downwards, right? So what do I know for definite? So it's going to be somewhere here. All I know for definite is that the I component is going to be 19. So it's going to be when the I component is 19, and that means I can find out what the T is and so on. So let's work that out. So if we do, we want to have the I component, so minus 2 plus 10t must equal 19. So 10t equals 21, so t equals 2.1, right? So when t equals 2.1. We get 9 minus 5t is going to be 9 minus 5 times 2.1 to give us minus 1.5. And that's going to be our j component. So the position vector of the ship will be, let's write it over here. So the position vector of the ship will be 19i minus 1.5j. So we know how far down it's going to be. So it's going to be somewhere here. So that's where the ship's going to be. I hope that makes sense.